Ladies and gentlemen, this short video cast will help you find velocity from the position time graph, and you'll need to use it on your Bubble Lab to complete part of the Bubble Lab results section. This is also very transferable to the test that we're going to be having next week. So completing this video cast and the associated paperwork will help you both complete the Bubble Lab velocity calculations and prepare you for next week's test. So you have a handout, and it looks somewhat like this at the bottom of the page. So our first task is to select 2 points on this line that you can estimate the coordinates for and that are as far apart as possible. So remember, our overall goal is to find the velocity based on this line. So let's begin by selecting the points. So let's start with this point. This point would not be a good choice because the time is easy to read, 8 seconds. However, we'd have to estimate the position at about 52. It's hard to tell. Here's another point that would not be a good one to choose. It occurs at 16 seconds. However, again, that would be an estimate of about 75 meters. So here's another one that is not as good as perhaps some of the other ones could be. This occurs at 30 seconds. However, it's difficult to tell what the X position would be. So let's look at some that would be better choices. We want to read choices that we want to make choices of our coordinates along this best fit line where it's easy to read the X value more accurately. Sometimes we don't have that choice, but usually we do. So let's begin by also acknowledging that we need the points to be as far apart as possible. So with that in mind, we want to start on the time axis over here at t equals 0 and begin looking right here for the first point that we can. It happens that this point right here at t equals 0 is a great position. So at t equals 0, the position is 20 meters. That will correspond with the initial time and initial position, and that can be recorded right over here as well. So we've pulled this off the graph, and let's record it over here on the right side of the paper. So next we're ready to find final position and final time. And so we want to look far along the graph. We don't want to choose something that's up here close. We want to look at something that's far away because that will give us a better quality result. So I would suggest that a good point is this one right here. At 24 seconds, the position is 120 meters. So 24 seconds, 120 meters is the value that you can use for TF and XF. So that value will then slide over in this position. So we have an initial time in position. We have a final time in position that we can then use in this velocity formula. So the velocity formula follows the pattern shown here on the screen, xf minus xi divided by tf minus ti. Go ahead and write that out in a way where you stretch it out. So go ahead and put a division line here and then subtractions on the top and bottom and leave space to drop in the values that we need to use. And if we look back up on this pattern, xf is going to be the initial term that we enter in the numerator of this fraction. So we want to look up here for the value for x sub f. So if we scan across here, here's the x sub f value. So we want to enter 120 meters in that location. Then we want to subtract from that x sub I. So if we look up here, x sub I was 20 meters. So that goes as the second entry in the numerator. Now we'll switch to the denominator where we're going to find the difference in time. So let's look at the final time. The final time was 24 seconds, so that needs to be included first. And we're going to subtract from that the initial time, as shown here. The initial time is 0 seconds, so that's going to come next. So when we do that math, 120 meters minus 20 meters, then we get 100 meters over 24 seconds. So the velocity is 100 meters over 24 seconds. We're going to simplify that mathematically, and when we divide 120 by 24, then we get a velocity of 4.167 meters per second. So hopefully this is helpful. Um, Please follow this similar kind of a format when you find the velocity of the best fit lines that you created on your bubble lab for each colored tube.